Okay, so now that we've translated our problem into symbols and we've used our prior knowledge to come up with equations that link the variables together, now we'll actually do some calculus. So what we'll do now to then bring the derivatives into the whole situation is we're going to take the derivative with respect to time of both sides of our equations. So notice for this equation, the derivative of v with respect to time is dv over dt. Pi over 48 is a constant, so the derivative of a constant times a function, remember, is that constant times the derivative of the function, which is 3 times h squared. And the derivative of the inside, the derivative of h, is dh over dt. So that's our derivative. We can clean this up a little bit. Let's say dv over dt equals, and then the 3 and the 48, we know from before, 3 becomes 1, 48 becomes 16. So we can write our derivative as pi over 16 h squared dh over dt. And that's the main equation we'll be working with. However, just realize that this equation, you can also take the derivative of both sides and get something. It's just that here we won't be using it later. But if we took the derivative of both sides, the derivative of this side is 1/4 dh over dt equals dr over dt. So if the problem would have called for it, we could have used this. But again, with the particular steps we've taken, we're not going to need that. But we'll be working with this in our next step.